analysis. I'm just giving this because what are the possibilities available in NLTK library. Next, I'm using snowball. This is also another step one. I'm just again sending the list of 4 words. You can see the output. Having is having, it gives have. So STEM, it is not much useful. So there's another thing called lemmatization. What does lemmatization do? Again, stemming, there's another process called lemmatization. It also cuts the word into, it converts the word into root word. But see, for this purpose, I'm taking the NLTK library, putting WordNet and WordNet lemmatizer. I'm storing WordNet lemmatizer as word_lem. So for, like we are dot stem, here lemmatization, we have to use dot lemmatize. So that I was sending a list of words, but here I'm giving just a single word for illustration purpose. So I'm sending a word gives. Gives is a verb. So I'm sending a gives. It gives us the root word give. So given, as given, had given. Gives. So everything is the root word is give. I'm going to give. So everybody will understand if somebody says gives or give. So when you say gives, it's a singular thing. You say gives. He gives to me. Similarly, if it's a plural, you say they give this book to them. So it is not necessary for analytics. It is not necessary whether it's a singular or a plural. What we want is a root word because it saves the character. Main thing of stemming and lemmatization is it takes out, it gives only the root word. So it removes yes. As I said earlier, having it converted into have. So ing is removed. It saves number of characters. Next is stop words. What are stop words? So as you know in English, in NLTK library, you have a lot of stop words. Totally, Len gives the total number of stop words in NLTK library. Totally, we have about 179 stop words. So for illustrative purpose, I'm importing a library NLTK corpus. I'm importing a stop words, and I'm storing it in stop_words, which is equal to stop words dot words. For this purpose, I'm going to use the language. It can be French or German, anything. So it is essential to mention the name, language name. So I'm going to give, since I'm using the English text for analysis purpose, I have to give the language name. It is English. So as I said, what are the stop words? I'll explain now what are the stop words. But we have 179 stop words in English. So why are we doing okay, first I'll explain what are stop words, then I'll explain why are we doing this stop words. See, again I'm giving the same example. B. I live in Chennai. It is the capital of Tamil Nadu. I Chennai. Okay. So after word_tokenize, I have got a list of words with a single word. Everything is in single quotes. I live in Chennai. Okay. So what I want to know is whether all these words is essential for our analysis. It is not like in stemming and lemmatization, we cut short some characters. Similarly, in stop words, we can remove certain words which are not required for analysis. Even if those words are not there in our analysis, the meaning will not go. I'll just explain now. So I'm creating a stop words. It's a list, empty list. Okay. I'm creating a loop for result in word_count. So what is word_count? Word_count is the list of words I live in. Okay, first time I send the word I. What is I? I is a pronoun. So for result in word count, then what does it do? It comes to the next loop. If is not in stop words. So we don't know what are the words in the stop words in NLTK. So we have to just so I'm sending first I. If I is a stop word, then it will go to the loop. It won't come to next. It won't add that word. Suppose, for example, if I'm using I, suppose if it is not a stop word, then it will come to the next one. In the list of that I have already created an empty list. In that list, it will add the word I. This process will go on until the period. But it starts from I. It will come up to the period, last period. So whatever stop words are there in NLTK, it won't come in the list. A_stop words will not have that collection. It will remove all the stop words. Only other than stop words, it will be there in the list. I'm just seeing here. Now I'm printing the A_stop words. You can see now, I live Chennai. So previously we had I live in Chennai. Now the word in is not there. It has removed. That means it is obvious that in is a stop word. So without in is also, when somebody says, I live Chennai, maybe he's not speaking correctly, grammatically he's not speaking correctly. But you can understand, he's trying to say that he's living in Chennai. So similarly, the computer will understand even if you don't use certain words, it will understand. So what is the objective of stop words? So when you send the text, see, we're doing a review. So we have to send a lot of text. It will have sentences and words. So we are removing the stop words. Even if you remove the stop words, the meaning will not change. So we are removing the stop words. The process will be very faster. And also, like using stemming and lemmatization, we are taking out the prefix or suffix. You are cutting the root. We are converting into a root word. Like I said, gives became a give. So you can see, I live Chennai. Previously, it is the capital of Tamil Nadu. Now you can see it is there. Is missing. Is a verb. This is the article, and you have capital of preposition. So certain verbs, articles, preposition are being removed by the NLTK library. So it cuts short our work. So it speeds up our work. So as of now, anybody has doubts? Word underscore tokenize. I talked about tokenization, stemming, lemmatization, and the stop word. Does anybody have doubt? I have doubt. You can give it in the chat box if you have. Okay. Okay. And now I will go to the next part. Parts of speech tagging. So you know what is the parts of speech? So in English we have 8 parts of speech: noun, pronoun, adjective, adverb, conjunction, intersection. So we have 8 parts of speech. So any word we can classify as, suppose India is a great country. You can say India is a noun, is a verb, A is a article. You can classify each and every word. You can tag that each and every word to some parts of speech. Similar to that, in NLTK, we have a thing called POS tag underscore tag. Okay. So what does POS tag underscore tag does? So it will tag each and every word. It will tag each and every word to one particular. Like I said, verb, preposition. We have a custom built tagging in parts of speech in NLTK. So it tags to that word. So you can see, I am using this, sending that list of word underscore count. What is word underscore count? It is a list of words. After tokenization, it is a collection of individual words. So I'm sending again that list of words inside the NLTK.pos underscore tag. You are getting this. See now, the I pronoun, it is tagging as PRP. Live, the verb it is tagging as VBB. See, what is the drawback in NLTK is in a natural or in ordinary in our English we had only 8 parts of speech. See, but you can see here the word live, it is tagging as VPB. Below you can see another verb. This is another verb, but it is tagging in different way, VPZ. So we have a lot of tagging available for each verb and noun itself. It is not consistent tagging. You have some special. There are some special purposes. But so what I'm trying to say is, it is not 8. It is more than 8 POS in the NLTK library. They are having some for certain purposes. Okay. So now I'm going to whatever I talk about is our pre-processing steps. Whenever you do any text analytics, it is not necessary that you have to do all those things. You're lowercasing the word, and you're tagging the word, and removing using stemming lemmatization, removing certain words, letters, and using stop words, removing the words that are not necessary. Even if you remove those words, the meaning will not change. The user can understand the meaning. Now I'm coming to the actual work. So I'm going to import 2 libraries, pandas and numpy. The alias name is, for pandas I'm using shortcut PD, and for numpy NP. These are all Python libraries used mainly for data analysis. So again I'm going to import another thing called OS. What does OS do? I have a collection, as I said in the notebook. it has a collection of data sets. So from that data set, I'm going to take one data set, and based on the data set, I'm going to explain. So the corpora is a collection of data sets. You can see Brown, Gutenberg, movie reviews, top votes, status samples. These are the data default data sets available in NLTK in Python, in Jupyter Notebook. So I'm going to use the movie reviews. Since today I'm going to talk about reviews. This is a classification model. So one more thing I'd like to say. So nowadays you have main four things: machine learning, deep learning, computer vision, and NLP. So among these four, NLP has huge demand. Next comes computer vision. Okay. So my today analysis is it is a mixture of NLP and machine learning. Just a second. So I'm going from this NLT corpus. I'm going to import movie underscore reviews. Okay, movie underscore reviews is the default data set available in Jupyter Notebook. As I told earlier, we are going to have only 2 reviews. Usually, as I said earlier, if you go to a restaurant or any training session, they'll be giving you a feedback form on a scale of 1 to 5. Any numerical value, they'll ask us to rate. But instead of giving a numerical value, instead of having 5 options, I'm going to take only 2 options, like 2 categories for negative and positive. And for each category, I'm taking 1,000. I'm giving equally. I'm distributing the negative reviews and positives equally. So you have about 1,000 negative reviews and 1,000 positive reviews. So these are the text file. If you can see the file IDs. I'm just taking out I'm using NEG category and taking the file IDs of all the negative reviews. You can try out in a text file. Just for this illustrative purpose, I'm taking a single negative text file. So you can see that I'm storing one single negative text file as REV. You can see that length of the REV is 804 words. So one person has given 804 words comments he has given. So I'm just printing the REV. So it is a list of words. You can see forgive, be, word, criticism. So it goes up to this list has 804 words. This TXT file has 804 words. Similarly, we have about 1,000 negative TXT files and 1,000 positive TXT files. Next, I'm creating a empty list. For review, I'm creating a empty list. So what I'm going to do is, I'm going to send all these words. Negative. You have a list of each review as a list of words. So 1,000 negative list of words I'm going to send inside this loop. So when I say negative review, first it will take the first TXT file. So the first TXT file is sent inside. It is taken as REV. So we can see it is the nltk.corpus.movie.reviews.words. The first text TXT negative TXT file is sent inside. So what is the main thing of? I'm going to join all those words. Now we can see only one text file is in the list. I'm going to collect all the 1,000 text file in a single list. That is the main objective of this code. Which I'm going to join it with using space, separated by space. So you can see here this list of words as a single quotes. You can see it has a single quotes and separated by a comma. So I want to remove this single quotes and separate and replace it by space. Similarly, I want to replace this comma by space. These 2 quotes will do that. Then after that, I'm appending in the empty list. I'm appending the first TXT file. So it will remove all the single quotes, comma. It will be stored in the review list. Again, the second TXT file of the negative will go inside. Since it is a for loop, the second will go. Similarly, 1,000 times it will be repeated for negative. So then you will have a one underscore list, which is a collection of all the words. So you can see. So Now you can see that review underscore. Now this is the main thing. Review on one string, then review underscore list. So just for the illustrative purpose, I'm taking one txt file. I'm printing it after rev. What is it? To party. Now you can see these are the words. Similarly, as we did for negative review, I'm going to do it for positive review. I'm going to take all the file IDs. Now that there will be 1000 file IDs. So when I enter yes, it will give me all the. You can see the length of positive review is 1000. So I'm listing all the positive review text file. Each text file is each text file is a positive review. So totally about 1000 text files are there. Again, as I did for negative review, I'm going to send this 1000 text file inside the for loop. So you'll be getting another. You'll be getting another review. You can see this review list. Previously, it had 1000 negative reviews. Now, since I'm sending this, I'm storing in review underscore list, it will become 2000. Because the 1000 negative review plus positive review will add up to 2000. See, now you can see the length of the review list is 2000. So as I told earlier, our system computer will not understand text analytics. It understands only the numerical values. So the output it is positive or negative. I'm for negative values I'm going to give 0. For positive value I'm going to give 1. Okay, this is the target. What is the target? Y. Y is the target output. It is either 0 or 1. So since it will be positive or negative, but we have to represent with 0 or 1. 0 for negative reviews, 1 for positive reviews. So for this purpose, I'm using NumPy. So again, I'm creating an empty target underscore list. It's an empty target list. So you can see this is a negative targets. Yeah, this is a NumPy array of 1000 zeros. This is another NumPy of 1000 ones. So the entire thing I'm setting inside. It will be first 1000 txt file. It will allocate 0. The next 1000 target list, it will be 1000 ones. We had about 2000 reviews. The first 1000 will have 0 values. The next 1000 will have 1 value. So you can see the target list after sending all the loop in the for loop. We can see we have about 2000 values. Now I'm going to do the machine. I'm going to use the machine learning algorithm. So you know in Python, it has a thing called data frame. What is a data frame? Like in Excel, each cell you can denote it by rows and columns. Similarly, if you have a collection of rows and columns, it is called data frame. But if you have only one column, it's called as series. The output, the Y is a collection of 2000. First 1000 is zeros and next 1000 is 1. So in Python, you can see here the index starts from 0 and it goes up to, since we have 2000, length is 2000. As in Python, the index will start from 0, not 1. So it ends in 1999. Okay, so this is the output value. So there is a library called, like I told about pandas and NumPy, there is a library called scikit-learn. Short form is sklearn. It is a machine learning algorithm. It has a lot of linear regression, logistic regression, naive-Bayes, lot of algorithms it has. I'm going to today for text analytics, I'm going to use naive-Bayes algorithm. So before going into this, I'll stop this presentation. I'll show you a different thing. I'll explain it using another screen. Okay, before I go to that machine learning algorithm, are you able to see my new screen?
Yes, sir.
Oh, thank you. Okay, so I'm just giving. I've taken 4 sentences. I'm just going to what are the machine learning will do, or what is behind the scene. Maybe the machine can do it in quick in few seconds, but we need to know what is happening behind the scenes. So for that purpose, I'm just going to give you I'm going to illustrate using 4 different sentences. So this will convert the text into numerical value. So for this purpose, I'm importing a Panda library called Pandas. As I said earlier, there is a library called Pandas for data analysis. So from sklearn, scikit-learn, it's a short form of scikit-learn. I'm importing count vectorizer. Previously, I was having different string. Now I have a list of sentences. You can see this corpus as this is the first document, this document is the second document. So totally this list has 4 sentences. Okay. So I'm importing vectorizer and using this as an imported count vectorizer. I'm importing and using this store, save it in vectorizer. Then using the vectorizer, I'm going to fit and transform. These 4 sentences will be fit and it will be transformed using this corpus. So then I'm going to get feature names. So you can see this. We have about 4 sentences. This is the first document, this document, second document. Okay. So what I'm printing X underscore names. You can see, even though you have this uppercase, this is here, and then lowercase, this is here. It is taking it is, as I told you earlier, it is automatically converting this uppercase also into lowercase this. Okay, and we have totally 4 this, but we have only here 1 this. So what is this X names? Actually, when you insert documents or sentences inside the computer, it takes only the unique codes. The and document first is all the, even though you have repetition, it does not give you the repeated words. It takes only the unique codes. So and it is also arranged alphabetically. You can see and is in the 3rd document, but here and is in the list of words, it is in the 1st position. So what does this count vector does is it contains only the unique words. I'm giving just for example 4 sentences. How many sentences you give, it will take only the unique words and it will create a list of words and it will arrange it alphabetically. Okay. So you can see here this 0, 1, 2, 1. 1 second. So now you understood and document. Now suppose, for example, see I told this is now I'm changing this to ngram. See, if you want any doubt, you can just, if in Jupyter Notebook, you can just press Shift tab. It will take you to the signature. You can see what are things inside. So you have input lowercase is equal to, see, as I told earlier, the system is doing lowercase is equal to true. So you have stopwords. See here, stopwords is equal to none. Previously I was giving stopwords in English. No? Now see, in vectorizer, it is not considering the stopwords. That is why we add this. Now we add those things. Now let me illustrate. Now I'll just give inside the stopwords inside. Let's see what happens. Now we have only list of 2 words. Document section. All this is the I don't know. So everything has gone. This is the use of stopwords. Similarly, now I have taken only one word here. Suppose I give ngram. I talked about bigrams, trigrams, ngrams. Suppose I give ngram here 2. Let's see what is happening. Now this list has unique words, but previously we had 9 unique words. Now everything is paired. Since ngram I have taken 2, so each list has 2 words, and they are all unique words. So okay, so this is and see previously lowercase was equal to true. Now I can see why I'm saying this is because these are default things. For your analysis, you want to do something, it is possible to do. And with any machine learning algorithm, we can change the thing. That is what I'm trying to say. We can tailor your tailor this Python notebook machine learning algorithm for your analysis. So now I'm changing it to lowercase is equal to true. So I'll put lowercase is equal to false. So default is lowercase is equal to true. I will change it to false. Now you can see this uppercase, this is also there, lowercase, this is also there. So anything, just you have to go to the thing, just press shift tab. It will give you the signature. Any code in Python, Jupyter Notebook, any Python thing, if you just press shift tab, it will give you the signature. It will give you in whatever thing is there. This counter, I'm using counter tracer. This is a function which within the parentheses, everything is argument. So you have to, these are the default, lowercase is equal to true. So suppose you want the lowercase to be false, you can change. That is what I'm trying to say. You can tailor it to suit your needs. So it is also not necessary to give because it is default. So I need not give. Only if you want to change something else, you want to give. Since lowercase is equal to true is default, I need not give that. See, I'm changing this is a X. I'm changing it to array. So now we can see what is the first one. What is the first sentence? This is the first document. Okay. So and totally you have 9. Totally you have 9 unique values. Okay. So totally you have 9 columns. So what are the unique values you have? Similarly, you will be having that much number of columns. And since I have 4 sentences, each sentence is a row. This is a n-dimensional array. So each sentence is a row, and you will have how many unique values you have. That much number of columns you will be having. So you can see I'm going to talk about this sentence. This is the first document. Okay, this document does not have and. So what is the first letter and? So since it does not have first and is 0, what is the next is document? Where is the document coming? So this is document. We have one document. So the second unique one is document. So I'm putting 1. Next is first. So the third one is since you have first here, I'm going to put 3. So this is how it goes. Here you can see the second document. You can see this document is the second document. You have 2 documents. The document appears 2 times in the second sentence. So we can see in the second row against the document column, your total number of document is 2. So this is how it converts the string into words into numerical value. Suppose, as I told earlier, I'll talk about data frame. So I'm using this x.to array and columns is equal to x name. X name is these are the unique words. You can see this is a data frame. I'm converting using this x names and this df is a data frame. I'm using pandas.data frame. I'm converting this numpy array into a data frame. As I told earlier, data frame is a collection of rows and columns. As I told earlier, the row in Python, the row index starts from 0, not 1. So you can, since we have 4 rows, but you can see it starts from 0, it ends up at 3. And all the 9 unique values, it is there in the column. So against each word, you can see that if the word appears in that row, you will have an entry. If the word appears multiple times, you can have multiple entries. So this is how the work of, just for illustrative purpose, I use these 4 sentences. Now I'll again go back to my machine learning algorithm. I'll stop presenting this and I'll go back to other screen. Maybe I'll just stop for 3 minutes. Anything questions you have, you can ask me. Now I'll present again. I'll present another tab. I'll go back to the machine learning algorithm. The participant has asked me a question. Let me explain. Okay, maybe I'll explain. I'll explain to him after the session. Okay. So I stopped here from SQL. This count, I was talking about count vectorizers, stopwords, lowercase. I just went to the another tab just to give you an illustrative purpose. I used 4 sentences. So now you would have understood. Now see if I'm using the same count vectorizer. I'm going to this review list as 2000. Previously, in the example, I had 4 sentences. Now this review underscore list will have 2000 reviews, list of sentences. So everything again, I'm doing the same procedure. You can say X underscore names, getting feature names. So similarly, I converted that into an array and used data frame. See, you can see the similar thing here. Since I told in Python the index starts from 0. So since we had 2000 reviews, so you can you can see from 0 to 1999. These are the unique values 00, 000, 007. So all the unique values are in the columns. So this is a 2000 rows. Since this is a 2000 rows into 23,784 columns. So you have about 23,784 unique values. Okay. Previously we had about 9 unique values in that 4 sentences. Since this 2000 reviews had a lot of sentences in each review, you can obviously understand the size of the column. We have about 23,784 columns. Now I'm going to use. Now I'm coming to the machine learning part. So I'm going to use again sklearn.model selection. So train underscore test underscore split. So I can. There are many ways you can do this analysis. I have about 2000 sample. I can send the entire 2000 sample for analysis, and I can take a new sentence from some people, third person. I can take a sentence. I can input that sentence. I can make a conclusion. But instead of doing that, I'm splitting my 2000 into train and test. Train data, test data. So what is the test size? I'm giving 0.25, which means for analysis, I'm going to send only 1500 reviews inside for training purpose. The 500 test data, I'll keep it aside. Then that I'll check later whether my model is predicting correctly or not. For that purpose, I'll keep aside that 500 reviews. So these are the X is the X. What is the X? X is the sentences, comments given by the user. Y is the 0 or 1. 0 for negative, 1 for positive. So in machine learning, you have a lot of algorithms for linear regression, logistic regression. So machine learning mainly, in machine learning you can mainly there are 2 things. Either it is regression, or you can narrow it down to 2 things. Either it is regression or classification. So this is ours is a classification. This is a binary classification. Either it is 0 or 1. This is not a regression. This is a binary classification. But as I told earlier, the machine will not predict 0 or 1. The machine cannot predict as 0 or 1. Okay, the machine will predict only like linear regression. It will predict a numerical value. Okay, it will be 0.5 or 0.6, 0.7 something. Like we are classifying the students. No, if the students get 60%, it is first class. 70% distinction. We are classifying based on marks. Similarly, we can tailor we can based on some analysis, previous history or previous data, we can fix a threshold. It is called threshold. That 60%, 75%, we are keeping. What is the benchmark? Similarly, if you think anything about 80%, 80.80, we can consider as a positive review. It is up to the people who are in the domain. It depends upon domain to domain. So this is I'm talking about the movie domain. There are some restaurants, hotel industry. It is service sector. A lot of service sectors are that, like training. So I'm giving a training session today. So for a training session, you can fix a benchmark differently. And it also depends upon the organization. So it depends upon various use case. Organization, it depends on the organization and the industry. So a lot of things go into this fixing the bench threshold. We call it threshold in statistical terms in this analysis. So the machine cannot predict 0 or 1. We have to fix a threshold. The default threshold is 0.50. I have taken the analysis. The default, the machine will take 0.50. Suppose you want to change that threshold, you have to write a code. In NLTK or Jupyter Notebook, you have to fix a probability. Usually the probability will be between 0 to 1. Okay. So it will give you a value. So you have to write a code. If you want to change, like I change, no, lowercase is equal to true, lowercase is equal to false. The default is lowercase is equal to true. Suppose I want to tailor it to false, it will give me capitalization of all the words. Similarly, I can change the threshold. The default threshold is 0.50. Okay. So this naive Bayes is useful for text analytics. So I'm going to use two algorithms using from a naive Bayes. One is Gaussian naive Bayes. The other algorithm is multinomial naive Bayes. That is, I'm just using this for illustrative purpose. So what is how much accuracy each algorithm is giving? So again, I'm from SQL. I'm importing a metrics. What is metrics? So you know in metrics day-to-day life, you would have in various organizations or in education institutions, you'll be having metrics like how many people have pass percentage, toppers. These are all metrics. Productivity, quality. So these all in industry we say productivity, quality. In industry education institutions we talk about pass percentage, those things. So those are all called metrics. So I'm from SQL. I'm importing metrics. Okay, I'm importing Gaussian. First I'm using this algorithm, importing this algorithm, and storing this as a variable GNP. So using GNP, I'm going to fit this model. So as I said earlier, I'm not sending the entire 2000 reviews inside the model. 0.25, 500 reviews I have allocated for test, which I'll check whether my model is predicting or not correctly or not. For that purpose, I'm taking the 500 thing. Only 1500 I'm going to send inside. You can see I'm sending the model X train, Y train. Only 1500 entries I'm sending, and based on that, it is going to predict using X test. I'm not giving Y test. You understand? So using this X train is what? This is a list of sentence, list of words. What is Y train? Y train is 0 and 1. That is 0 and 1. So using this 1500 data, I'm going to give the other 500. It is going to, based on this thing, it will train a model. It will create a model, and using that model, I'm going to predict. I'm not going to give here Y test. I'm going to just give the sentence. The model it is going to predict. So once it predicts, that I'm storing it as Y predict. This is not the actual value given. Actual value. This is not the actual value. This is not a Y test value. This is the predicted by the model. After giving the X test, this model is giving the Y predicted value. So now I just want, as I told you earlier, you have a function. You have a thing called accuracy underscore score. So there I'm giving the two things. Actual, what is the X test? For this X test, you'll be having some Y test, isn't it? Whether it is 0 or 1. So those Y tests are actual values, which we have with us. And this is the machine predicted values. It can predict 0 or 1, anything. So I just want to see how is the accuracy. So for 66.2% is the accuracy, which means that around 330 it has correctly predicted. I have given 500 reviews, out of which only 330 it has predicted, 336 something it has predicted correctly. So this is a very bad model. So and also one more thing, I'm just giving you for illustrative purpose accuracy. When you do a classification analysis, so when you do a classification, as I told earlier, the main thing in ML is regression or classification. This is a binary classification. Whenever you do a classification thing, we just don't accept the based on the accuracy score. Some certain other parameters also there. I'll explain later. Okay. So I'm creating a confusion matrix. So using what is a confusion matrix? I'll explain below. Okay. For inside the confusion matrix, I'm sending the actual value, Y test. Y test is the actual value. And this is the machine learning algorithm. This Gaussian naive Bayes, it predicted. So you can see this says 2 cross 2. Because always the confusion matrix will be 2 cross 2. So now before going to the other model, I explained what is a confusion matrix. You can see here it is a 2 cross 2 matrix. Okay. I'm sending actual values and also the predicted values, and based on that, it is giving me. So now I'm coming down. So now I'm going to explain what is confusion matrix. So in classification problem, this is a binary classification problem. Okay, let us take an example. Let us take an example of now. Since we have a lot of corona cases, we'll take corona cases. Okay, this is the actual value. This is a positive means is positive is a corona patient. Negative means is actually is a negative patient. So I'm taking this blood test. So just for illustrative purpose, I'm giving an example. You are sending the blood test to the lab. Okay, this is the predicted value. When the person has corona and the lab result is also positive, correctly predicted as positive, then it's called true positive. TP means true positive. Okay, when the actual value is positive and the lab result is giving me negative, this is false negative, because it is not positive. It is not actually, it is positive. The actual value is positive, but the predicted value means the lab result. You can take that here in this case, corona case, you can take that lab result. So it is negative. So positive patient, it is predicting as negative. It is a very serious issue. See, maybe for text and movie reviews, okay, this is understood. For certain industries like healthcare and all, no, we can't have a false negative too much. Why I'm saying this is the confusion matrix. So for negative, suppose the person is negative, he doesn't have corona, and the lab result is giving us positive. Okay, a false positive. Suppose the person is negative, and the lab result is also giving negative, it is true negative. So what are the correct things? True positive and true negative is correctly predicted. Okay, suppose you're doing analysis, the diagonal, you can see the diagonal value, TP and TN. These are the correctly predicted values. Whereas this side diagonal, FP and FN, it is wrongly predicted. See, okay, so why I'm talking about accuracy score is, so every time our model cannot go based on accuracy. So this model has 66%. I'm using another model, it is giving 80%. Just because we had good accuracy, we can't go 80%. We can't think that this model is good. See here you can see what is the, you can see that as I said earlier, what is the false negative? False negative is 59. Suppose this is the text and this is movie review. Okay, 59 reviews are wrongly classified. I understand. Okay, I can ignore, or I can make some other. I can tune the hyperparameters. But suppose in case of corona, I cannot have 59% being wrongly classified as it does not have. It is negative. Okay, it is very life threatening. So it depends upon the health industry. So in healthcare industry, you can't have. So out of the 500 samples, you can't have 59, 69, 60%, which is around 10% is falsely predicting as negative. It is very dangerous. So it depends upon the industry to which thing will give importance. So this is the confusion matrix. As I told you earlier, we have other parameters also. Previously, I was talking about accuracy. What is accuracy? Accuracy is true positive, true negative. How did you get this value? It's 80%. This. See, we got about 66%. Okay, if you add this value 162 plus 169, how much is it? 320, 331. So 331 out of 500. So this is true negative, this is true positive. So this accuracy means it is taking, this is the formula. Accuracy formula is true positive plus true negative divided by all the values. So what next is sensitivity. Like in the healthcare industry and all, they'll be very, they'll give too much importance to this sensitivity. They not give importance to accuracy. Accuracy is also one of the parameters. So this classification model, we have a lot of things to what I'm going to say. So now you don't judge you don't say correctly. You don't say this model is very good based on one parameter. There are a lot of other things you have to consider. Like one such thing was accuracy. So as I told earlier, in the healthcare industry, if you go by accuracy, our model is very bad. It has wrongly predicted corona patient as false negative. Okay, so in certain type of instances, you have to use sensitivity. As you see the word sensitivity, it is very sensitive. It's a very sensitive issue. It is a true positive rate. TP is true positive divided by TP plus false negative. Actually, false negative means it was actually positive. So you have to see out of the total positive patients, how many the model is predicted correctly. That is called sensitivity. Okay, as you can see, the FN means false negative, which means it is positive. It is also a positive, but our machine is not predicting correctly. So the sensitivity is the ratio of how many people have been predicted correct, how many reviews have been predicted correctly out of all the correct positive reviews. Next is precision. Similar to sensitivity, accuracy, you have another parameter, another thing called accuracy model, metrics called. So these are the metrics. So we don't decide based on one metrics. You have to, in classification model, we can't judge whether this model is good or not based on one particular metrics. That is what I'm trying to say. It depends upon the industry also, for which you do the analysis. Next is precision, specificity. Next is F1 score. Okay. Next, I'll talk about ROC. These are the two things, ROC and AUC. Okay. ROC stands for receiver operating characteristic, and AUC stands for area under the curve. First, I'll explain what is area under the curve. Okay. First, I'll explain ROC. So ROC is this x-axis is false positive rate. As I said, as I told earlier, this is the sensitivity is true positive. Sensitivity is true positive rate. Okay, false positive rate is 1 minus specificity. Sensitivity is the true positive rate. 1 minus this specificity gives the false positive rate. So our x-axis is the whatever values false. You know the values. You can predict the values false positive rate, and y-axis is the true positive rate. So based on this, you fix the values. So this is the ROC curve. So as I told earlier, our random model is 0.5. Our threshold is always 0.5. So this is a diagonal. So this is the, so you can see 1 minus specificity is a false positive rate. Sensitivity is true positive rate. So you have to maximize sensitivity and minimize false positive rate. You understand? So you have to take a value. What is the objective of doing this ROC curve is you're going to find the threshold. You're going to, as I told earlier, this model defaultly takes 0.5. But I want to find a particular value which maximizes true positive rate and minimizes false positive rate. 1 minus specificity stands for false positive rate. Sensitive means the other name for sensitive is recall or true positive rate. So based on this, you get a value. So So this black color circle denotes confusion matrix. As I told earlier, for the default threshold is 0.5. So I have taken one confusion matrix. This is 0.5. So for various values of confusion matrix, you can calculate true positive rate and false positive rate, isn't it? So this is the default 0.5. This for 0.5, I calculate the true positive. This is the true positive, true negative, true positive. I'm calculating true positive and false positive. So I can change my threshold from 0.5 to 0.6 or 0.5. So for various values of threshold, these circles are a confusion matrix. Okay. So for each threshold, I can take a confusion matrix, and from confusion matrix, I can predict. From confusion matrix, I can take the true positive rate and false positive rate. Sorry. So you can see the y-axis is true positive rate. It ranges from 0 to 1. Similarly, from x-axis, we have false positive rate. It is also from 0 to 1. So as I said earlier, I want to take a value which maximizes my sensitivity, that is true positive rate, and minimizes 1 minus specificity, which is the false positive rate. So if you can see this one, this third. One second. Okay. You can see from the last, if you can see the third one, the third black circle, it has the maximal is 1. It has the maximum value, and also it has the lower. It has the x value also. It is very less. A false positive rate. If you can see that it has the maximum value 1, but you can see the false positive rate also when compared to other two TPR values. This TPR has less false positive rate. So I can choose this as the receiver operating characteristic, and then I can take this as threshold. I can use the confusion matrix for our analysis. Okay. This is the main classification. You have a lot of metrics. One such metric is receiver ROC, receiver operating characteristic. Next, I talk about AUC, area under the curve. So similarly, for I plotted ROC for one model. Here I'm the second. If you can see the second graph, I am plotting ROC for two models. I just want to know, based on this, which model is better. So previously I talked about accuracy. We talk about accuracy. This model was Gaussian model gave 66% and multinomial model gave 80%. So as I told you earlier, we can't go based on one metrics, and that too accuracy is a bad metrics. We have to take other metrics also for our classification purpose. We have to see which model is better. So we have to plot this both the how many other models you are doing for analysis. You have to plot all the models in the like this. You are like true postulate, false postulate. You have to plot, and which model has the area under the curve, which has large area. If you can see the model which has pink color. It is from top to bottom. It is in pink color. Okay, the model which is in blue, it is not, that area is not much. Only the pink. It starts from top to it goes up to the bottom. But you can't see the pink color in the bottom. But it is understood like that. It starts from top pink color. It goes to the below the up to the x-axis 0 value. So that model has large area. So something like that. So since here we had two models, Gaussian NP and multinomial NP. So you can predict the values using the threshold. So whichever model has more area, we can take that model as for our analysis purpose. So this is how I started with introduction to. So now the sentimental analysis is over. Since I'm going to talk about pandas using a data set, Titanic. So before I go to pandas hands-on with another data set, I'll stop for 5 minutes. Anybody is having doubts, they can please tell me in the chat box. Please.
So there is a question from the chat, but how to find the characteristic sentence?
Sarcastic.
What do you mean by sarcastic? Can you define what do you mean by sarcastic? Many words you can understand. You can give many meanings to sarcastic, but from your point, I want to know what do you mean by sarcastic?
Excuse me, sir. The question was posted by me. Sarcastic is basically you tend to say something, but you try to tend in a very different way. Maybe you want to say that this is very bad, but instead of saying it's very bad, you try to say, oh, this is so good. You want to give other word, but you try to express in a different words. That's what the sarcastic means.
See, the machine learning, like text analytics, you have certain models like this is the NLTK is a basic model. Okay, so now people don't use NLTK. Just for illustrative purpose, I use this NLTK. Another library called Spacey and Stanford NLTK. But now in the recent days, people are using BERT. There is another model called which is deep learning. I'm using machine learning algorithm. Now, as I told you earlier, machine learning, deep learning, computer vision, and NLP. So now people are using deep learning techniques. So deep learning techniques, one such model is BERT, GPT-1, GPT-2. So as you said rightly, so some sentences you also use certain positive or negative word before the sentence, like no percentage, something like the model actually it will take it itself will understand. You have I don't know about the NLTK. I have not done that, but you have some nowadays you have a lot of good models using deep learning. Whatever you said, it will take care of those things, those parameters also, like BERT, GPT. And still research is going on. All those things are being taken care of. Any other questions from the participants? Are you able to hear me? One participant said in a very low voice. Hello? Ma'am, are you able to hear me?
Yes, sir.
Yes, sir. Yes, sir. We are listening, sir. Thank you, sir.
No, no. Two of the participants, the chat box have said a very low voice. Just want to know, test whether it is very audible or not.
It's audible, sir.
Okay, thank you, ma'am. Okay, now so since there are no questions, I'll go to the second. I'll go to my data analysis using pandas. Hands-on data analysis using pandas. Now I'll change the screen. Okay. Now I have finished my sentiment analysis. Now I'm going to talk about data analysis using Python. I'm just going to give a hands-on, just going to give my hands-on on using pandas library. So pandas is mostly used for data analysis. So I'm going to ask you. I'm going to import pandas and NumPy. So most of the participants would have watched the movie Titanic. So I'm going to use the Titanic data set. So it is going to predict whether the passengers survived or not. Okay. So these are the column names. This is a CSV file. So this pd.read_csv. This is the command. This is, you know, as I told you earlier. If you just go to Shift tab, it will give you all the what all you can read. Either you can create a data set or you can take from the net. Okay, this is the Titanic data set. You know, you have seen the movie Titanic, that the ship went and dashed against some object in the sea, and a lot of people died. So this gives the name of the passengers, the age, the class in which they traveled, the ticket, the fare, the cabin in which they stayed, and what is the sex of the name of the person, what is his sex, what is his age, and what is his cabin, first class, second class, those things. So totally, I have taken for this purpose, I have taken 891 rows. You can see 891 rows and 12 columns. Okay, so this is a data frame. As I told you earlier, this is a dynamic data. I'm reading the CSV. It was a CSV file. I'm reading.
Excuse me, Madan sir, your screen is not visible.
Oh, sure, 1 second. Are you able to see now, ma'am?
Yes, sir.
Yes, sir.
Sorry for the inconvenience, ma'am. Okay, again I'll explain now. So this is I'm going to import pandas and NumPy. These are the main tools for data analysis in Jupyter in Python. So as I said earlier, I'm going to talk about the Titanic data set. Most of the participants would have watched the movie Titanic. So the Titanic was a mishap. It happened in last century, which where the ship went and dashed against the iceberg in the sea. So most of the people died. So I'm having the details of 891 passengers. Whether the passenger survived. If he survived, it is 1. If he died, it is 0. And that P class stands for that you have in the ship as in the train, right? You can see in the train you have first class, second class, sleeper class. Similarly, in the ship also you have passenger class 1, 2, 3. And the name of the passenger, it is his sex, his or her sex, age, and siblings, whether they travel with any brothers or sisters, and those things. These are the details, ticket, fare. Okay, totally for my analysis, I'm taking 891 rows and 12 columns. As I told you earlier, data frame means it is a rows and columns. As I told in Python, the index starts from 0. So the first passenger, its ID will be 1, but whereas for analysis it will be 0 because of the index it is all built in the Python. So similarly, like CSV file, suppose if I use an XLS file, if I am going to import read an XLS file, I'm going to use the command Excel. Excel. So you have many options. If you press Shift Tab, 1 second. I'm not able to get it. So you can read other files also. text files, anything. So I just I'm giving only 2 examples: CSV file, Excel file. You can read multiple files, and we also, instead of reading from internet or down from other thing, we can also create a own data frame. So I'm creating a own data frame. You can see pandas. PD stands, it's alias name for pandas. PD.data frame. Data frame is a collection of rows and columns. So this is a parenthesis. I'm giving a dictionary. In Python, you have like list. You have tuple, sets, and dictionary. The dictionary, you can see colon. The first word before the colon is the key. So whatever is after the colon, it is called value. Okay. So I'm creating 2 columns and I'm creating 2 columns and 3 rows. So name and age are the columns. For the name, I'm giving ABC as the values, and for age, I'm giving 2, 3, 5 as the values. So I created a data frame with 2 columns and 3 names. So again, you can see the index starts from 0. Okay. So when you have more than 1 column, it is called a data frame. Suppose I'm filtering only one. I'm taking only 1 column. I'm taking the Titanic. Titanic is a data frame. First of all, this is the process. First, you have to give the data frame name. Then you have to, whatever column you want to take, you have to put enclose in square brackets. So you can see I'm taking a one second. And I can take a different column and take age. You can see now first is the Titanic is a data frame. This is the protocol. So whenever you want to filter something, filter rows or columns, so first is you have to give the data frame name. Next is the whatever columns you have to give, you have to enclose it in a square brackets. So whenever you have only 1 column, it is called series. So you can, as I said earlier, you have 2 things in pandas. See, if you press type, it will give you the whatever thing is that you can get. See, type is the keyword. I'm typing what is the type? It is a series. So when you have only 1 column, it is called series. When you have more than one, see, I'm typing here. Suppose now it was previously, now it was series. 1 column, if I type, it is giving us series. Suppose I'm going to use another one. I'm going to give another one. Text. It's a 2 columns. So when you have more than 1 column, you have to give another parenthesis. You have to enclose it in parenthesis. So, okay, what I'm trying to say is, just if you have only 1 column, it is called series. If you have like I'm giving only 1 column, it is called a series. When I give 2 columns, like here, it is called a data frame. You can see that I'm giving type and I'm giving 2 columns. So it is giving data frame. That is the difference between series and data frame. Pandas is a good library for data analysis. Next is the shape. Name of the data frame is Titanic. What is the keyword tells? Shape means it gives us the number of dimension, 891 rows and 12 columns. So the shape thing, it will give the number of rows and columns. Tells us the number of rows and number of columns. Next, suppose you want to know what are the columns are available in this data set, Titanic data set. So the Titanic.columns gives us the number of columns, names of the columns. You can see passenger ID, surveyed, passenger class, name, sex. These are the names of the columns. Next is data type. This for everything you have to give the data frame name. I have stored this data frame name as Titanic. So data stands for data types. So in pandas, you have mainly three data types. Integer means like integer value 1, 2, 3. float means like 1.1, 2.22, that numerical value with some decimal. Then you have object, like your name, age, sex, sorry, name, sex is male or female. So it is a string. Whenever if you have alphanumeric or a string, it is called object. So now I'll talk about list. Okay, X is a variable. It's a list. It has three values. Okay. Suppose, as I told earlier, the index in Python, the index starts from 0. So I'm accessing the first value. So you can see when I give H subscript, I'm putting in parentheses, square brackets. If I give the first value, first index 0, it is giving me 2. Suppose it starts from 0 to it goes on. So if I give 2, you can see it gives 5. So there are two ways of doing this. Either you can start from 0 or from the reverse side, -1. So I'm say 5. If you give 2, index 2, it is giving me 5. Suppose if I use -1, so then also it will give 5. I'm using -2. So I'm accessing the data from the reverse side. Either I can start from front side 0, index 0, something like that. It goes on, or either from the last. If I'm going to access the data from the last, it has to be from -1. So there's a thing called head. See, as I told you earlier, this dynamic data set had 891 rows. Suppose I want to know the first 5 rows. There's a command called head. So data frame name, everything you have to use a data frame name. So Titanic is I have stored this as Titanic. You can see this is what is it? This is the data frame. Titanic is the data frame. So I have to use the data frame name everywhere. So this data frame dot head. So it gives the first 5 rows. If you want to see the last 5 rows, you have to give tail. Suppose you want to tailor it only 2. So you can give, suppose I want only 2. Then you have to enter the numerical value inside the parentheses. You can tailor this to suit your how many other rows you want. You can enter the numerical value. Next is there's the function called name. See, certain passenger names will not be consistent, or will not be what do you call it? Will not have a correct name. So for example, suppose if the name column, if they are given different some other name like number, so you have to rename the column. So those things can be done by the word rename. Data frame dot rename, and within that parenthesis you have to give columns is equal to. So I'm going to rename only one. So again, this is a dictionary. Before the colon, this is the old name. Passenger is the old name. Okay, it has I uppercase. I'm going to change it with lowercase I. So if you give this passenger ID, it will change into ID. Let us see. I'm going to insert. Okay. So I'm entering again. I'm going to enter Titanic. First 2 rows. I'm going to see first 2 rows. See, I changed the column name I to lowercase. If you can see here, I rename the column using the rename function. Uppercase I changed it to lowercase I. But see, it has not happened. Why? Because I'll tell you, it will not happen just like that. Either you have to, if you can press Shift Tab, you can see the signature. Okay. See, this is the signature. If you can keep the cursor next to the rename and just press Shift Tab, it will take you to signature. The signature you can see a lot of things: index, columns, axis, in place. So that's a thing called in place is equal to false. Okay. So in place only when you change in place is equal to true, the change will happen. Either you can do this way, or you have to assign it to again into Titanic. Either there are 2 ways. Like either you can put your in place is equal to, or you have to assign it to Titanic again, to the Titanic equal to. So this is there are 2 ways. This is one way. Either after changing the renaming the column, you have to assign it to the same data frame. This is one way. The other way is, as I told you earlier, as I told now, it is you have to use the word in place is equal to true. So now if you see that change has now taken place. See now we can see now. So now you can see that there are, as I told you earlier, there are two ways of doing this. Either you can assign the same this thing to Titanic data frame, or you can put a word called in place is equal to true. So now you can see the I, uppercase I, has been changed into lowercase. Next is another thing is called describe. So what is the describe? So whatever numerical columns you have, this you can see sex is not a numerical column, name is not a numerical column. So passenger ID, survey, P class, siblings. So those are wherever you have numerical values or float values, it will give the count. It will give. See, these are the three. We had about 12 columns. Only 5 columns. Only 7 columns have numerical values. So it gives us, as I told you earlier, we had 891 rows. So it gives us the passenger ID 891 rows. Only you can see in age under age you can see 740, 714, 714. The rest of the columns have 891 values. Okay, what does it mean? Which means that we have some missing values in under age. Under age column, we have some missing value. I'll complete later, and I'm just like you have see like you have mean. What is the mean age of the passenger? We had a lot of people traveled in the ship. The mean age is 29. Like how many people survived? As I told you earlier, 1 is for survived, 0 is for not surveying, is that. So as you can see 0.38 means 38% survived. Suppose there are the 38%, suppose there are 1,000 people would have traveled in the ship, around 3,380 people have survived. Rest of people they died. So this mean gives us the value. So 0.38 stands for, so you'll come to know like 0 means death, 1 means survived. So 0.38 the numerical value, it tells us 38% of people have survived. So these are the basic statistical things, minimum, maximum. So you can see the minimum age, maximum age. So maximum age of the person who travels the ship is 80. Okay, and fare also. What is the minimum fare? You can see the maximum fare is 512. So suppose I want to see now this. I want to interchange the rows and columns. Then there is a command called .t, which stands for transport. Now see the count. Whatever it was in the row, it has become in the column. It has been reversed. So that this will be useful. See now you can see all the columns. The count is 891. Only in the age you have 714. So what does it mean? It means that you have some data. There are some missing values inside the against in the age column. You have 891 rows, but in an age column you have some certain missing values. So these are things we do in data analysis. In the pandas, any missing values generated by NAN. Which you can see here. See, NA, you have a lot of NAN, which means that it's not a number. It is a short form for not a number. So previously I was using when I gave a describe within parentheses, it was taking only the numerical. Whichever column had numerical values, it is giving the count mean. Suppose I am interested in having all the columns. So in that case, you have to use the thing include is equal to all. Okay. So now even the object, the text alphanumeric, age, sex was a male, female. So now even for that purpose, for that column also, you are able to do something. But you can see for age and all, sex and all, you can't say the mean value. Okay, because see, if you take the sex, you have 891 count. What are the unique? It says 2. So obviously, unique values are 2 because it can be only male or female. So you have 2 unique values, and the top values it says as male, which means that around about of the 891 passengers, 577 people were male. So this is the top value. Top. It means that you have male and female, but most of the passengers were male. So if you want to include all, it will give the. If you want to include even the string float object columns also, it is possible to include in the describe. So describe gives you a first before starting going to the actual analysis, you will be able to identify the missing values, the mean value. Certain times the mean value will be something like, suppose age of the person will be -25, which means it is not correct. Sometimes the person who is entering the data, you can enter wrongly also. No human being can have -25 and all. So these things are the errors and all we can see. if you see the minimum value, suppose if it's minus 25, you can identify just some wrong data. So this is mainly for finding out missing dead values, something wrongly classified, those things. And as I said earlier, you have a lot of data types. Suppose you want to filter only data types which have object. Object means string. So you can see name is an object, sex is an object, male, female, ticket is an alphanumeric, cabin. So whichever data whichever columns add a string or alphanumeric, those things are comes under object. Next, as I told earlier, isNull is a function. isNull, I'll just talk about isNull. For everyone, always you will be using the data frame name. So Titanic is the data frame name. So I'm using everywhere. So if you use isNull, so for all the rows and columns, it will give wherever the value is NaN, it will see here in the first row. You can see under the cabin, you have some true value. So there are some missing values, I think so. So missing values is indicated by true. Wherever it is not, you don't have missing values, it will be false. So there is another thing called, just you want to know how many missing values are there for each column. This is the sum. As I told you, age. There are some 177 missing values are there. Cabin, it was showing to fall true, no? You can see 687 missing values for cabin. Embark, you have 2 missing values. So this is the thing. Using this, you will be able to identify how many data are missing in each column. So as I told you earlier, if you use, so I'm going to filter. Suppose I want to take only 2 columns. I want to see previously when I give title. Sorry, one second. So when I enter Titanic, whenever I enter Titanic, the entire data set I'm able to see. So sometimes you will be very specific. You will be very you want only particular row or particular column to be viewed. So you want to filter those things. Every time you don't want to see the entire 891 rows and 12 columns, isn't it? So you have some lot of options for filtering rows and columns. So one such, see if you give in square brackets, it will filter the columns. So I'm interested only in the age and cabin. So it has given me, it has filtered out only the age and cabin. This is for filtering the columns. Okay. Now you have another option called LOC and ILOC. LOC stands for location. ILOC stands for integer location. You can filter the data based on LOC or ILOC. See, for this you have to give first type data frame name dot LOC. Okay. So what is it? I'll explain what is the difference between LOC and ILOC. You yourself will come to know. See, this is the first thing is column rows 2 to 3. Okay. I want only all the columns, but the second and third row. So 2 to 3. So suppose you want, this is I'm using the colon. Suppose I want 2, 4. I want this second and fourth. Suppose you want to, just because this has a continuity 4 to 6. Suppose you want to split the values. I'm very particular, only selecting certain rows which are not very neighbor, which are not near to them. Then in that case, I have to use another thing. I have to use another list 2, 4. Okay. You can see. You have to, because you are using a list, I have to include another square bracket. If there is a continuity, I need not use this square bracket. You can just type 2:2. So now this gives us the row. Suppose I want the column also. I want the column. I can give that's a comma, whatever column I want. Suppose I want name and sex. So again, I can put a list. Put whatever I can filter name, comma, sex. Now you can see the first. So in LOC, the first if you don't give the column name, it will list all the columns and the corresponding rows. Suppose the LOC, the first part is the row, the second part is the column. It is separated by comma. Suppose if you don't give any column, all the columns will be default. It will print all the columns. The corresponding rows only row index. This is the row index 2, 4. This is for LOC. So the same thing I'm doing. Suppose I'm doing I'm using this. As I told you earlier, if this is not sequential, then I have to use a square bracket. This 2 column 3, it is very sequential, very nearest 2 and 3 are very near to them. So in that case, I don't need to put a square bracket. That is the main difference. So you can see in the LOC, we use for columns, we use name. We don't use the value. Okay. For LOC location, we use the name of the column, not the index. But for integer location, but for the ILOC, you are using only numerical values 2 and 3, 2 to 3, the fifth index, fifth column. So and one more thing, LOC and LOC. See LOC, both the rows came. 2 and 3 it came. But if you use ILOC 2 to 3, the last it will take -1. I'll just illustrate again. You can see it starts with 2. The index starts with 2 and it goes up to 4. But if you use ILOC, you don't print 2, 3, 4. It will take the -1. 4 minus 1 is 3. So second and third row is printed. Which is the fifth index? The fifth index is 0, 1, 2, 3, 4, 5. Age is the fifth index. So you can see age is the fifth index. So this is the age value. Fifth index is age. So this is the second row passenger. It is or your age. This is the third row passenger. Is or your age. So these are the things we use LOC and ILOC to filter out rows and columns. So LOC will be using name against the column, and ILOC stands for integer location, where we'll be using the numerical value for column. That is the main difference between LOC and ILOC. These are this will be mainly useful for filtering out the data. So next thing, as I told you earlier, there are another thing called NumPy. Like pandas, you are using data analysis. There is another thing called NumPy. So from numpy.random, I'm importing a rand int and I'm giving a alias name as RI. Rand int is what it will generate random numbers, integer numbers. So instead of float numbers or some other number, it will generate integer number. So I'm using the RI alias. So I'm storing it in a variable A. RI, 4 is what? 4 is, as I told earlier, in Python, in Jupyter Notebook, you have an option called Start Tab. So if you press Start Tab, it will give you the signature. So it is not necessary to remember all those things. Just you type whatever you want, just press Shift Tab. So first is the low. The 4 is the lowest value. So this our random number will generate starting from 4. So I values, here it is none. I am given 10. Size, it is given as none. I am giving 3 cross 3. 3 cross 3 means 9 values. It is a NumPy array. Totally it will have 9 values. So you can see all the 9 values. It is between 4 to 10. 4 is the starting value. 10 is the highest value. So using this randint function, I am able to create a 3 cross 3 NumPy array. All these values, all these elements are values between 4 to 10. Okay. Now, as I told earlier, I can read from data from out CSV file, Excel file, text file. I myself can create a data frame using dictionary. Earlier I was creating using a dictionary. Now I'm going to create using some other thing. The data frame df is equal to pd.data frame. A is what? A is the NumPy array. Okay, this 9 cross 9 is the NumPy array I'm creating. This is the A. Columns is equal to, so usually default columns, as I told you earlier, in Python, it will start from 0. It starts from 0, whether it is for column or row. All the index will start from 0, default index. So I'm changing it. Column name is ABC. Index, as I told you, instead of 0, 1, 2 default index, I'm customize my index, low, medium, high. Okay. Now when I print the data frame, you have 3 index, low, medium, high. They're not values, they are just index. Instead of 0, 1, 2, I'm giving my user defined index. I myself is defining and giving an index. And row column names are ABC. So again, if you can see, I'm using the LOC function. When I give, previously I was giving for LOC, I had to give, I can give only a numerical value or a string value. So this medium, I'm giving the medium, it is giving me 766. Okay. So instead of the df dot, I can give ILOC. I am giving what is the medium? It is the index number 1. See. Okay. See. So I'm just giving an example. So I'm accessing the same row using the default index. When you have string as index, you have to use LOC only. You can't use ILOC. So this medium is 0, 1. The medium index is 1. So for when you use the numerical value, you have to use ILOC. So for that purpose only, I gave this default index. So the main difference between LOC and ILOC is ILOC will not take any string value, only it will take numerical value. LOC will take both numerical value as well as string values. So as I told you earlier, if you want to filter any column, see I'm filtering a DFA. So since previously it was 0, 1, 2 index, now since I have given the default index, customized index, it is giving me low, medium, high. So you can also create a new column. I earlier had 2 columns, A and B. Suppose I want to add A and B, 7 plus 5 is 12, 7 plus 6, 13. I'm going to create a new column D using the first 2 columns, A and B. So that can also be, that you can also do the data analysis. See, D adding 2. So we're giving a value 12, 39. So suppose, suppose certain times when you get a data from the data set from any user, any industry or somewhere, so you will have a lot of columns. Those columns will be unnecessary. It is not necessary for our analysis. So those columns are not, okay. So okay, as I told you earlier, in data set, when you get from any industry or customer, so you'll be giving your raw data. It will be mostly it will be unstructured. It will not be in rows and columns. It will be very, you have to pre-processing itself will, our data analysis, suppose 100% of the work, 80% of the work will be pre-processing, removing punctuation, top words, unnecessary pictures, those things. We have to, that is the main pre-processing. 80% of the work will be for pre-processing. So certain columns you have to drop, certain rows you have to drop. So to drop a thing, there's a function thing called data frame. Since now I have shifted from Titanic data frame to another data frame which I used here, DF. Okay. So I'm dropping this df.drop. I want to drop that column B. So axis is equal to 1. Okay. You can see when you say axis is equal to 1, it means it's column. So you have the option of dropping either the row or the column. Suppose if you want to drop the column, you have to give axis equal to 1. If you don't give anything, it is taken as you have to drop. It will give me error because axis, you are not B column is B string is in column name. So you can see the default axis is 0. It will drop only. You can see the signature. The axis is 0, which means row. Okay. So here see I want to what are the rows? I add low A, B, C. So the axis is equal to 1. If you give, this will work out. For dropping a column, you have to use axis is equal to 1. So axis is equal to 0 is the default value. You need not give. So okay. Now you want to Now filtering rows and columns using values. Previously I was filtering using column names and row index. Suppose I want to in particular A column, I want to see all rows which are 7. Since I have given three rows A, B, C, A, C, D, I want to filter only those rows which have value 7 in A column. So you can do that. See, first is the data frame. Within the square brackets, you have to give again the data frame. Then this is called subscripting. You have to give the column name which you want to filter, and this is the you have to give double equal to. Okay. So if you do that, it will list out all the you'll be able to see all the columns, all the rows which are A value, which has A value 7. See, you can see previously we had three rows. Now I'm interested only those rows which are for which A column has 7 value. So similarly, like you can instead of filtering one value, you can also use multiple columns. Previously I was filtering one column. Now I can filter multiple columns, A and D. Then you can also reset index. Previously I was using an index, index as low, medium, high. When I do this reset index, it becomes on the default index will 0, 1, 2 will come, but this index does not disappear. So for that, what you have another option called, this is the signature. So you have certain options to do that also. You can take out this also. You can remove this in the default index also. See, okay, drop is equal true. This is the reset index. I'm resetting the index to 0, 1, 2. I'm using the thing called drop is equal true. When I say drop is equal true, the index which I tailored, it goes out. The index it goes out. Now you can have the original index 0, 1, 2. So you can also suppose, see, I have 4 columns, 3 rows. Suppose I want to replace 7 with 3. I have some value 7. I want to replace all those 7s with 3. I can do that. See, I'm replacing the 7 with 3. We can see wherever 7 was there, everything got changed to 3. Okay. So you have a lot of other things is there. I think so. I'm nearing the time. So you can also fill the NA. So you can see there's one column which has value NaN, not a number. Suppose you want to fill this number NaN with some particular value, whether 45. Sometimes you want to filter with the mean of this column. See, this is the D column. So you can also fill out, either you can fill with the individual value, or you can fill with the mean value. So 13 plus 9 is 22. So when you give mean, it will take the mean value. It will filter missing value with mean value. So a lot of things, substitutions can be done. See, I told you, no. So I'm replacing with the mean value. You can also replace with other things also. So one more thing. Okay, and before we finish, one important thing I'll talk about. This is called the group by function. Again, I'm going back to the data frame, Titanic data frame. See, in sex we have male and female. So I'm interested in how many male and female. I'm not interested particularly only about not all the passengers. I want to classify them into male and female. Okay. So first I created a group by object. When I give this, I added Titanic dot group by. This is the column name sex. Whichever object you are interested in grouping, you have to enter that inside the parenthesis. Next, I want to know what are function you want to do, whether it's mean or minimum, one thing. So I'm interested in mean of this sex group by. So now you know sex, it is grouped into female and male. Totally we have about 800, total about 931 passengers. So you can see it is forget about the passenger ID because it is a numerical value from 0 to 931. So you can see the female age is mean age is 27, female age is 30. The female passengers, they are paid a mean fare of 44. So a lot of things you can do. You can use a lot of things. So with this, I'll stop. Any participants, if you have any doubts, please ask me. I'll stop this presentation.
Yes, sir. I think no questions on the chat box. There's one.
Ma'am, are you able to hear me?
Yes, sir. There is one question on the chat box. Difference between Gaussian NB and multinomial NB.
I don't have a clear picture. That is one of the types of airbase. Maybe I can, maybe later on I'll explain. As of now, I have no clear picture. It is one of the airbase type.
Sir, good evening, sir. This is Dr. Agasthyar, HOD BCA.
Good evening, sir.
Good evening, sir. Good evening, sir. Your session was very wonderful, sir. I watched from the beginning, sentiment analysis. I think it is really useful for the research scholars, those who are doing research under machine learning and data mining. So the session was very useful. I think for the data set analysis, how the data set is working, how the Python libraries are accessible through this data sets, those things are very much interesting. So I hope the session was useful for the participants. Initially, the participants are very less, but after some time, it may be increased, sir.
Okay, sir. Thank you,
Anyway, I think it's useful. Madam Syamala ma'am.
Yes, sir. We got 50 participants today.
Yes, madam. பார்த்தேன் ஆரம்பத்துல 30 இருந்தது அப்புறமா 50 ஆயிடுச்சுல
50. We got 50.
50 participants. Yes.
But when
But
compared to the registration, I think many have not turned up. We have got
yes,
more
ma'am.
than 250 registrations, but many
100.
have not turned up. Yes, sir. Okay.
But anyway,
So
most
we can.
participants were asking about feedback in the beginning of the session. Someone asked about that. But anyway, someone they are simply participated. The maximum of the participants they were involved.
These are
Yes,
good
sir.
numbers, ma'am. And sir,
Yes, sir.
these are
Yes,
good
sir.
numbers
Yes.
actually.
Yes, madam.
So, like we can see
And
most of the participants from yesterday. So that is
Yes,
very
yes, ma'am.
good. Like they are continuing their participation. So hope the same thing will ensure till Saturday to get
Yes.
practice on this one. Yes, sir.
Yes,
Sure.
madam.
Thank you so much for your support, sir. Thank you so
Yes,
much for your ma'am as well.
Thank you,
thank you,
madam.
thank you,
sir.
Sandhya. Thank you, sir,
Thank you,
Madan,
sir.
sir.
Okay, I'll take to
Thank you, madam,
Okay,
sir.
we can.
Sir, thank you.
Madan,
The
sir.
session was wonderful.
Thank you.
Thank you, sir.
Thank you, sir.
Sandhya ma'am, for giving me the opportunity to talk.
Annie ma'am, you got some link where you can get the reading source are available.
Yes, ma'am. Yes, ma'am.
You can
Thank you,
check.
ma'am. Thank you so much. I saw that. Thank you so much.
Okay, sure. Thank you.
And thank you. The session was really useful and really appreciate the resource person's important input. Thank you so much, sir. Thank you everyone for organizing this webinar. Thank you.
Thank you.
Welcome, ma'am. Thank you.
Madam.
Thank you, madam, sir.
Thank you, sir.
Ma'am, feedback link, you're Pushpalata ma'am, you're asking for feedback link or reading source link? Resource link, okay. One second, sir. Sorry, it is there in the creators one.
So I think we can end the session, ma'am.
I'm trying to.
Okay.
Ramya
Yeah.
ma'am, the session is over. Thanks for your
Yeah.
participation.
No issues, pa. Thank you. Thank you.
Thank you, ma'am. Madan sir, I'm removing everyone, so you can also leave. Thank you so much for your informative session.